Good day, everyone. It's another opportunity for us to learn. I'm ARVIN Enriquez, your instructor for differential calculus. With this video lesson, we're going to discuss functions and limits. So with this slide, let's deal with the functions. So before dealing with these functions, let's recall what algebra brought to us. No, what are the concepts of algebra brought to us in terms of functions and relations? So the first question is, what is the difference between your function and relation? So by simply recalling the definition of a relation and a functions, no, from our algebra, no, when say relation is a set of ordered pairs, the domain of a relation is the set of first coordinates. The range is the set of second coordinates. So your domain is your x coordinates and your range is your y coordinates. Then a function is a relation in which each element of the domain corresponds to exactly one element of the range. So we can visualize more this definition by simply dealing with a set of ordered pairs. So when we say function, if there is a given set of ordered pairs, as long that there is no repetition in your x value or in your x coordinates, then the given set of ordered pairs is a function, regardless regardless of if there's a repetition in your y values or y coordinates. For example, if the set of ordered pair is equal to 1, 2, 3, and 4, then 5 and 6. So 1, 3, and 5, that will be your x values or x coordinates. Meaning, say, there is no repetition in your x value. That's why the given set of ordered pair is a function. Meaning to say, a function can be a many-to-one or a one-to-one relation. But what if, sir, if the given set of ordered pairs shows that there is a one-to-many relation? Meaning, say, the set or the given set of ordered pairs is a relation and not a function. Dealing with this definition, so when two quantities x and y are related so that for some range of values of x, the value of y is determined by that of x, we say that y is a function of x because there are possibilities, no, that if x increases, your y also increases, or if your x decreases, your y also decreases, because we use letter y to represent a function. So it can be f of x, r of x, s of x, q of x, m of x. So we simply use this letter y to represent those functions. So the value of your y will always be dependent on the value of x. That's why if x increases, then your y also increases. If your x decreases, your y also decreases. Or there are possibilities that if x increases, then your y decreases. It depends on what the function can bring to us. So we say that y is a function of x. For a square with side of length c, the area, no, the length c, the area is given by a, that will be your area. Your c is the length of the square. Now, there is a given condition here that your c is greater than 0. Because in reality, there is no such thing as a measure of a length, no, which is less than 0 or equal to 0. So there is no negative values of length or equal to 0. So the value of length of any closed figure should be greater than 0 or a positive number greater than 0. That's why if your C increases, your area also increases. So therefore, A is a function of C. So the range of values of C being determined by the physical meaning of the quantities involved, because in reality, the length of any closed figure must be greater than 0, and it should be greater than 0 all the time, and not equal to 0 and not less than to 0. Because in reality, there is no such thing as negative value or 0 as a value or values of your length of a closed figure. So after dealing with your area as a function, so let's have some or more examples about these functions. So let us recall as examples now the six trigonometric functions: your sine x, your cosine x, your tangent x, your cotangent x, your secant x, and your cosecant x. Now, with these functions, no, uh, we define the value of your sine x by simply dealing with the values of your three sides of a triangle. For example, your opposite side, your adjacent side, and your hypotenuse. So mean you say if these three values no increases or behave on the same manner, there's a bigger possibility that the value of your sine x, cosine x, your tangent x, your cotangent x, your secant x, and your cosecant x will behave the same way that these variables are behaving. Next, the square root. Y is equal to square root of x. So we can rewrite this one as y is equal to your x raised to 1 half. So your square root sign here no represent your 1 half here as your exponent. So that will be the value. That's why we can rewrite your y is equal to square root of x by simply using your 1 half as your exponent in your x variable. Or we can rewrite this one as y is equal to x raised to 1 half. But we consider this as a function if and only if we satisfy this condition, that your x is greater than or equal to 0. Why is that? It is important that x is greater than or equal to 0 because in every function, in every x value that we're going to put, or in every number that we're going to put as a value of x there should be a value of y. So it can be negative, 0, or a positive number. As long that there is a corresponding value of y, in every x values that, or in every number that we're going to put as a value of x in your given function, it's fine. But we need to satisfy this given condition that x is greater than or equal to 0. Because square root of 0 is 0, meaning to say if x is 0, your y is 0. So there is a corresponding value. And if x is equal to 4, a positive number, no, square root of 4 is 2. Meaning to say if x is 4, your y is 2. So there is a corresponding value. What if we put a negative value as a value of your x? So square root of a negative number is a math error. So therefore, it cannot provide you a value that will be mapped on the values that you put, no, as a value of x there. If the number that you're going to put as a value of x there is a negative value. So there is no y values that will be mapped on that negative number. That's why it is important for us to know that we need to satisfy this condition if we're dealing with this square root sign. Because your x should be greater than or equal to 0 for us to provide a value of y. Then, the next thing is that the linear polynomial. So y is equal to mx plus b. So if you try to recall the concept of a line, no, the slope-intercept form in your geometry or analytic geometry, that your y is equal to mx plus b represent the slope-intercept form, wherein your m is your slope, then your b is your y-intercept. Now, how can we graph a line by simply using uh, the values or the sign of your slope? We say that if your slope is a positive value, your line rises from left to right. If your slope is a negative value, then your line falls from left to right. So that's how we deal with your linear polynomial. So when you say dealing with this linear polynomial, uh, from the word linear, so there is a word line here. So meaning to say the highest exponent that you can see, in your equation with a given equation is equal to 1. So your highest exponent here is equal to 1. There's a 1 here, pero nile-neglect na po natin yan or hindi na po natin nilalagyan because it doesn't affect your values. So, but in this case, with the given equation here of a line, your highest exponent is 1. That's why they call it as a linear polynomial. And then next is the quadratic polynomial. So dealing with this quadratic polynomial, your highest degree is 2, or your high exponent that you can see on this equation is equal to 2. So what are these equations? These are equations of a circle, ellipse, parabola, and hyperbola, and many curves, no? So meron pa pong iba, some curves that uh, can be represented using a quadratic polynomial. So hindi lang po siya limited to your circle, your ellipse, parabola, and hyperbola. But these four are the most common, quadratic polynomial. So with the equations of your circle, ellipse, parabola, and hyperbola, so you can graph this one, or we can graph this quadratic polynomial in different forms in a way of the circle, ellipse, parabola, and hyperbola. Again, dealing with your quadratic polynomial, your highest degree is equal to 2. And you need to check, if we put a values of x here, then there should be a value of y. So we cannot consider this one as a function if we cannot provide a value of y if we input a value of x here. So if we input, for example, x is equal to 1, then it provides you y is an imaginary, or it provides you a math error thing, then the given equation is not a function. So you need to check before you conclude that these quadratic equation represent a function or not. So it can be a relation, or a function. There are times, once we apply your horizontal and your vertical line test for us to see, if the given graph is a function or not. So for example, in your circle, so if we apply your no when we apply your vertical line test, so there are 2 point of intersections between your graph and your vertical line. Therefore, this graph no of a circle is not a function, it's a relation. But consider as a quadratic equation. Now, dealing with your ellipse, same thing with your ellipse. So this ellipse is not a function, but a relation. Because at some point, no, in one value of y, there are two values of x. So meaning say there are two values of x that can provide you only one value of y, or horizontal distance of a point to your y-axis. Then your parabola. So there are cases wherein we consider your parabola as a function. If your parabola opens upward and downward. And what if your parabola opens in a rightward manner or in a leftward manner? Then your parabola is not a function. We only consider the graph of a parabola as a function if the parabola opens upward and downward. Same thing with your hyperbola, no? If this is your hyperbola, no? Once we apply your vertical line here, no? There are two there are two point of intersections. That's why we cannot consider this graph of a hyperbola, no? Even if your hyperbola opens downward and upward or leftward or rightward, no? Regardless of uh, its opening, no? We can consider this hyperbola as a function because you cannot satisfy or justify the concept of the vertical line test. That there should only one point of intersection between your graph and your vertical line test before we consider that the given graph is a function. Now, this circle, ellipse, and hyperbola, no, these are quadratic equations, but dealing with these quadratic polynomials, sabi ko nga kanina, there are uh, curves, no, that will represent a quadratic polynomial in a way that you satisfy that this curve, no, will represent a function. For example, your parabola nga, when your parabola opens upward and downward, then the given parabola or the given graph of a parabola is a function. So we use symbols such as f of x, which is feed f of x to denote a function of x. So we write y is equal to f of x. So we use y to represent a function. So it can be f of x, u of x, r of x, m of x, o of x, no? So to convey the fact that y is a function of x, we just simply put a values on it, no? So if we put the values of x, so there's a possibility that your y uh, increases or decreases once your x also increases. So if we put a numbers, no, as a value of your x, then your y or your function is also increases in a way that if your x increases, or in another way, no, if your x increases, your function or your y decreases. The same thing if your x decreases. So there are possibilities that your y also decreases, or if your x decreases, then your y or your function increases. So for us to visualize more what is a function, so let's deal with this example A. So let f of x is equal to x squared plus 3. So we're asked to find the value of your f of 2, your f of negative 4, your f of 0, your f of u minus 1, your f of negative x. So let's deal with your f of 2. So if the given function is f of x is equal to x squared plus 3, then what is the value of your f of 2? Now, uh, in finding the value of your f of 2, we just simply substitute 2 as a value of x in the given function. That's why we replace x by 2. or by simply putting 2 as a value of x in the given functions. That's why f of 2 is equal to 2 square is plus 3 is equal to 7. Why we come up with that 7? Because 2 square is equal to 4 plus 3 is equal to 7. So this part is equal to 4. So 4 plus 3 is equal to 7. Now, let's move forward with f of negative 4. So we input negative 4 as the value of x in the given functions. So that will be negative 4 square plus 3. So negative 4 square is equal to negative 4 multiplied by negative 4. So negative multiplied by a negative number is a positive value. That's why negative 4 times negative 4, it's positive 16. So 16 plus 3 is equal to 19. Next, what if we're asked to find the value for f of 0? So we're going to put 0 as the value of x in the given function. So 0 squared is equal to 0. So plus 3 is equal to 3 because 0 plus 3 is equal to 3. Next, f of u minus 1. So what will be the value? So we're going to put u minus 1 as a value for x in the given function. So f of u minus 1 is equal to u minus 1 squared plus 3. So let's apply the concept of special product. So your special product says that your first term is the square of your first term. So that will be u multiplied by u, it's u squared. Next term, before going to your middle term or next term, you're just simply copy whatever your operations here. That's why it's negative here. Now, your second term is that twice the product of your first and second term. So if your first term is u, then your second term is negative 1. Then if we multiply this negative 1 to u, that will be a negative u multiplied by 2 because it's twice the product of your first and second term. That's why it's negative 2u here as your second term. Now, your third term is that the square of your second term, which is negative 1. So square of negative 1 is equal to a positive 1. So positive 1 here as your third term in this special product, with the concept of your special product, plus this 3. So that will be equal to 4. That's why it's 4 here. Because we add this 1 from your third term in your with the concept of your special product. So we add your third term to your 3. That will be 1 plus 3 is equal to 4. That's why it's 4. Now, how about your f of negative x? So we're going to put negative x as the value for x. So we simply replace all x value in the given function by simply using your negative x. Now, negative x squared plus 3 is equal to x squared plus 3. Or we can come up with the idea that f of negative x is equal to f of x. Or therefore, your f of negative x is equal to your given functions here. Bakit po nangyari yon? Because your exponent is an even number. As long that your exponent is an even number, regardless if your base is a negative number, if that is a negative value, as long that your exponent as is an even, is an even number. These are numbers, divisible by 2. So your resulting value is a positive value. That's why negative x squared is equal to x squared because your exponent is an even number. What if your exponent is an odd number? So the negative sign here will remain, will retain, with this variable. So if this is an odd number, for example, 3, negative x raised to 3, since 3 is an odd number, then the negative sign here, will retain with your variable. But with this example, no, our exponent is an even number. Therefore, the resulting value now is a positive value. So we can conclude now that f of negative x is equal to your given function, which is your f of. So for more example, let's deal with your example B. So let g of y is equal to cosine 2y minus 2 sine y. So we're asked to find the value of your g of phi, your g of 1 half phi, your g of 0, and your g of x plus your g of negative x. So from the definition of g of y, it follows that your g of phi is equal to 2 phi minus 2 sine phi. So we're going to replace y by simply using your phi because we're asked to find the value of your g of phi. Now, dealing with your unit circle, no, so if we convert this 2 phi, no, to degrees, so that will be 360 degrees. Your phi there is your 90 degrees. So if we want to input this one directly to our calculator, you need to check first if your calculator is in radian mode. It should be in radian mode before you input directly this cosine 2 pi minus 2 sine phi in your calculator. So please do check first if your calculator is in radian mode. So if in degree mode, no, then you need to set from degree mode to radian mode. If we're going or if we want to directly input this cosine 2 pi minus 2 sine phi in your calculator. So your cosine 2 phi here, it provides you a value of 1. Then your negative 2 sine phi here provides you is 0. So 1 minus 0 is equal to 1. So your final answer for your g of phi is equal to 1. Then next, for g of 1 half phi. So for us to find the value of 1 half g, 1 half pi, no? So cosine pi. Why is that it is cosine phi? Because from the given function, it is cosine 2y. So if we multiply 2 by 1 half phi, that will be phi minus 2 sine 1 half pi. Because there is no 2 here, as a numerical coefficient of your y there. That's why it's 1 half phi. Now, this cosine phi provides you a negative value. Then next, your negative 2 sine 1 half phi, it provides you a negative 2. Because since it's a negative value here, that's why it's negative 2. Now, in your cosine phi here, your phi will fall in between your second and your third quadrant. No? We know that your x in that two quadrants, from quadrant 2 and 3, I mean, your x is a negative values. Or all x values under that quadrants uh, are negative values. Now, let's move forward with your g of 0. So we're asked to find the value of your g of 0. So we're going to replace all your y values under your given function by simply using your 0. That's it. That's why we need to input, that's why we need to input your 0 as a value of your y in the given function. So cosine 0 minus 2 sine 0 is equal to 1 minus 0 or simply equal to your 1. Now, moving forward. So for the last thing, we're asked to find the value of these two combinations. It's a combination of two functions, your g of x and your g of negative x. So let's deal with your g of x. So we just simply replace all your y values in your given functions, replace lang po natin yan with your x, So may say, papalitan mo lang lahat yung y variable mo using your x variable. That's why it's cosine 2x minus 2 sine x. Now, let's move forward with this g of negative x. So we're going to use this negative x as the value of your y in your given function. That's why it's cosine negative 2x minus 2 sine negative x. So by simplifying, so that will be cosine 2x because the value of this cosine, no, with the value of this cosine, uh, or should I say we multiply this one, the entire ano, by a positive, by a negative value. That's why it's a positive value for from this simplification. That's why it's cosine 2x plus 2 sine x na with this condition. Now, no, why is that it is positive, no? Sabi natin nga, no, with our discussion with your unit circle, if your angle is a positive value, your, what will be the quadrant na first mong mamimit if yung angle mo is a negative angle? That will be quadrant number 4. Now, in quadrant number 4, your x or your cosine value is a positive value. That's why it's positive value here. No, ang explanation diyan bakit naging positive values po to, because your angle here is a negative value. So ang first quadrant po na mamimit mo if yung angle mo is a negative value, that is your quadrant number 4. In quadrant number 4, your x is a positive value or simply your cosine is a positive value, your sine is a negative value because all your x value, y value under that quadrant is a negative values. That's why your cosine, no, in your quadrant number 4, if your angle is a negative value, no, then your cosine is a positive value. That's why it's positive cosine 2x here. So here, this is a negative value multiplied by a negative value. That's why it's positive 2 sine x dito. I hope that is clear for us. So therefore, if we combine this one, so g of x plus your g of x, no, so since cosine 2x, both g of x and g of negative x have cosine 2x. So we combine this one by simply using 2 here because there are 2 cosine 2x. That's why it's 2 cosine 2x. If you try to look at this simplified form of your g of x and g of negative x, so it's a negative sign here and a positive sign here. Therefore, no, if we add these two, negative and a positive value of 2 sine x, then the resulting value is equal to 0. So I want you to correct this one. This will be sine x, no? It's a typographical error. It's sine x. So 2 sine x. So 2 sine x, positive 2 sine x minus 2 sine x will be equal to 0. That's why there's an plus 0 dito. Pero hindi na po natin nilalagay yung plus 0 dyan because hindi naman po makaka-affect yun sa ating value, ng values ng ating functions. So our final answer, if we're asked to find the value of your g of x plus g of negative x, that is 2 cosine 2x. Now let's deal with your graph of a functions. So in determining if the given graph represents a function or not, we simply use the concept of your vertical line test. So in your first graph, so once we apply your vertical line test here, so there is only one point of intersection between your vertical line and your graph. So meaning to say your graph number 1 represents a function. Now, is it one-to-one functions or not? So if we're asked to find if the given graph represents a one-to-one function, we need to satisfy both your horizontal and vertical line test. So if we apply a horizontal line test here, when we apply a horizontal line test here, there are three point of intersections between your horizontal line and your graph. Meaning say this graph is a function but not a one-to-one function. Again, in checking if our graph is a function or if our graph represents a function, we need to use the concept of your vertical line test. If there is only one point of intersection between your graph and your vertical line, then the given graph represents a function. Now, An additional thing, no, if we're asked if the given graph represent a one-to-one function. So if there are point or more point of intersection between your horizontal line, no, and your graph, then the given graph is not a one-to-one, or this the given graph did not represent a one-to-one function. So before we consider that your graph represent a one-to-one function and a function, no, you need to satisfy both your vertical and your horizontal line test. Next, in your second, no, same scenario with this one, no. This is a parabola that opens in a rightward position. So once we apply your vertical line here, that will be your vertical line. No, there are 2 points of intersections. So meaning say you you don't need to use your horizontal line, no, to check if the given graph is a one-to-one, because at first you did not satisfy your vertical line test because there are 2 points of intersections between your graph and your vertical line. Therefore, this graph is not a function. So same thing with this third graph, no? We apply your vertical line. So there are 2 points of intersections between your graph and your vertical line. Therefore, your graph is not a function. Again, before we consider that your graph is a function, we need to satisfy the condition that your vertical line test brought to us. That there should be or there is only one point of intersection, no, between your graph and your vertical line. And if you're asked if the given graph is a one-to-one function, you need to satisfy both your horizontal and your vertical line test. Now, let's go now with the definition of your limit. So in differential calculus, we define your limit as, so we need to use this concept. So let f be a function defined at every number is in some open interval containing a, except possibly at the numbers a itself. So the limit of f of x as x approaches a is L, written as. So if you try to look at this portion, no. So we use LIM to represent the limit. So the limit now, or the limit of f of x when x approaches a, the value is L. So that's a given condition. If x approaches a, no, with using this function, the limit of this function, if your x approaches a, or the value of your x becomes a, then the value of this limit of a function is equal to L. If the following statement is true, given any, your small Greek epsilon should be greater than 0. However, small, because these are small values. There exists that a sigma, or the small Greek sigma, is greater than 0, such that if 0 less than the absolute value of a, I mean minus a, is less than your small Greek letter sigma. So there's a given interval here, no, between your 0 and your uh, small Greek letter sigma, that the value of the interval between your x and a should fall in between your 0 and your sigma here, or the absolute value, I mean, no, of the interval being given in this one, because if x approaches a, so meaning to say there is a value before your x and there's a value after your a. So whatever your interval in between those values, no, it will fall here. Here, I mean, if 0 is less than the absolute value of x minus a, less than your sigma, then your f of x minus L, or the value of your function minus L, which is the limit of your function when your x approaches a, is less than your epsilon. So you need to satisfy this condition, no, that your f of x, or the absolute value of the given function, no, minus the given value of the limit of the given function f of x when your x approaches a, should be less than your epsilon here. So you need to satisfy these two conditions being given with the definition of a limit. So in mathematics, a limit is the value that a function approaches, no, approaches as the input, or index, approaches some value or values. For example, if our x, no, approaches 2 here, so there is a corresponding value of y. So what if our x approaches 3? So here there is a corresponding value of y again. That's why the limit is the value that a function approaches as the input, or index approaches some value. So we're going to limit, no, with the given condition. If x approaches 3, what will be the value of your function? So what is the limit of that function when x approaches 3? So we're going to consider this point as your limit now of the given function if x is 3. For example number 1, use the definition of a limit to prove the limit of 4x minus 5 when x approaches 2. So if you try to consider this one, no, if x approaches 2, so we're going to put this 2 as a value of x here for us to get the value of the limit of 4 of x minus 5 where x approaches 2. So that will be 4 multiplied by 2. Therefore, this will be equal to 8. Now, 8 minus 5 is equal to 3. So therefore, the limit of 4x minus 5 when x approaches 2 is equal to 3. Now, let's deal now with the limit theorems. So your limit theorem number 1, the limit of a linear functions. So we're pertaining to a limit of a line here. So if m and b are any constant, meaning to say that m and b are numbers. So m as the numerical coefficient of this variable x, then b as your y-intercept in your slope-intercept form, which is equal to y is equal to mx plus b. So if we're asked to find the value of the limit, no, of the limit of this mx plus b, where m and b are any constant, so these are numbers where m is your numerical coefficient under your variable x. So what is the limit when x approaches a? So we're going to replace x, no, with this equation, no, we're going to replace x by using your a. So we simply substitute a as a value of your x here since x approaches a. So the value of this one is equal to ma plus b. So there is no varying to your b using uh, dealing with the concept of your approaches a, no, with your b, because there is no variable x with your b. So your final answer in getting the value of this limit of mx plus b when x approaches a is equal to ma plus b. For limit theorem 2, limit of a constant. If c is a constant, then for any number a, so your limit c when x approaches a is equal to c. Why is that? There is no varying of this x approaches a. So if you try to look with this one, no, if c is a constant, meaning to say there is no involvement of a variable x here. So whatever your constant here, and you're asked to find the value of this limit of this constant, no, that when x approaches a, we simply, or this limit is equal to the same value of what the constant is, because there is no variable involved. So for example, if this is cx, no, this is your numerical coefficient. This is your variable x. But if you try to look at this one, there is no variable involved. So there is no involvement of your variable x. So whatever the value of your constant there, no, and if you're asked to find the value of the limit of this constant when x approaches a, simply that will be equal to the value of that constant, because there is no variable involved in this limit. For limit theorem number 3, so limit of the identity function. So if you try to look at this portion, this or you're dealing with a variable only. So there's a numerical coefficient that is equal to 1. In reality, that is 1x, but we don't need to put 1 there as your numerical coefficient under your x, because does not affect the real value of it, no. So that's why if we're asked to find the value of the limit of x, no, when x approaches a, that is simply equal to a. Why? Because we're going to substitute the value of this a to the given variable on your limit. That's why if x approaches a, and the only given in your limit is a variable x, no, with a numerical coefficient which is equal to 1, then whatever your is approaching, that will be the value of the limit of this x, no, when x approaches for some values. So that will be a. So since limit of x when x approaches a is equal to a, no, we need to take note of this one, because it will happen if and only if your numerical coefficient here is equal to 1. So if not equal to 1, then this is not a. So it's more than a, or it could be less than a. So you need to take note of this one. It happened because your numerical coefficient here is equal to 1. So your limit theorem 4. Limit of the sum and difference of two functions. So you need to consider this one, no? You need to consider this one. So your limit of f of x when x approaches a is equal to L. Then the limit of g of x when x approaches a is equal to M. Now, if we're asked to find the value of the sum and the difference of these two limit, no, or limits of the functions given to your f of x and your g of x when x approaches a. So since the same scenario, no, with this x approaches a, so same limit with these two given functions, no, that is simply equal to the limit of f of x plus or minus g of x when x approaches a, no, since same limit sila dito, which is x approaches a, no, that will be equal to L plus M, no, plus M is for sum. So that will be L plus M for sum, then L minus M for difference. So that's how we deal with the limit of the sum and difference of two functions. So if there's a given values of these two limits, no, as long that they have the same, no, as long that they have the same limit, no, where your x approaches a, no, so whatever their value, that will be the value if we're asked to combine them using addition and subtraction. Again, L plus M L plus M for the sum, then L minus M for your difference. So for limit theorem number 5, so the limit of the sum and difference of n functions. So we're pertaining to the n functions, meaning it's a multiple functions. So there's an involvement of multiple functions here. So there's a given function here, which is your f of 1 of x, or f sub 2 x here, then f sub n of x here, which is equal to your L and L sub n, L2 here, then L1 here. Again, as long that they have the same limit where your x approaches a, so we can combine these three limits or multiple functions here using the concept of sum and difference here. So same scenario with your limit theorem number 4. We just simply use the operation of your addition and subtractions. So L1, that will be the value of the limit of f sub 1 of x when x approaches a. Then L2 is the limit of f sub 2 of x when x approaches a, plus or minus up to the last functions involved in this kind of scenario, wherein your limit of your f sub n of x when x approaches a is equal to L sub n. So we just simply use the concept of addition and subtraction here in between. So we need to put an operation between your the given values of the limit being involved in this scenario. So that's it. So in your limit theorem number 6, so the limit of the product of two functions. So there's an involvement again of your two functions, no, with the given resulting value, which is L and M. Again, we can combine two limit of a function if they have the same limit, no, or your x approaches a. So as long na parehas po to, then we can combine two limits of the functions. Now, with the concept of this one, same scenario with the addition and subtraction, the only difference is that we apply the concept of product. So here, the operation between, no, the operation between your two functions, which is f of x and g of x, is multiplication. So multiplication po ang ina-apply natin dito. That will be equal to the resulting value of the limit of f of x when x approaches a, no, which is equal to L, multiply by the resulting value when we apply the concept of the limit of g of x when x approaches a, wherein that will be equal to m. So we simply multiply this one, L multiplied by m. That will be the resulting value if we're asked to combine, no, or we're asked to multiply this g of x, the limit of g of x, to the limit of f of x, as long that they have the same limit or values of x, or the values of x that's being uh that you are approaching, I mean, no, with this kind of scenario where x approaches a. So for limit theorem number 7, so the limit of the product of n functions. So here n function will represent the multiple, no, multiple functions na tinatawag po natin. So there's an involvement of your f sub 1 of x where x approaches a. So there is a resulting value of that limit that will be L1. Same thing with your f sub 2. So there's an L2 sub 2 dito. Then for your f sub n of x, when your x approaches a, so then you're asked to find the limit. So the resulting value is L sub n. So the only difference between your limit theorem 6 and 7 and your limit theorem number 7, there's an involvement of multiple functions, wherein the operation between these functions is multiplication. So you need to multiply the resulting value of your f sub 1, the limit of f sub 1 of x, no, when x approaches a, to the resulting value of your f sub 2 of x when x approaches a, then the limit of f of n of x when x approaches a, which is equal to L sub n. So you're just simply multiply this L1, L2, and Ln, as long that they have the same limit here that your x approaches a. So again, we just simply multiply this one, L1 multiplied by L2, multiply by the last value of the limit being involved, no, with the limit of x approaches. For the limit theorem number 8, so the limit of the quotient of two functions. So same thing with this one. So we're going to use the same value of your limit, which is your f of x and g of x. So same scenario, your x approaches a, the limit of this function f of x will be equal to L. Then the limit of the function of g of x when x approaches a is m. So we simply divide this L, no, L by m with this condition. So we only deal with this kind of limit, no, using the quotient of two function if we satisfy this condition, as long that your m is not equal to 0, or the resulting value of your denominator, no, here, the resulting value of the limit, no, of a function uh, from your denominator, it should be more than 0 or less than 0 but not equal to 0, because any number, no, divided by 0 will provide you an undefined. So there is no such thing, no, with this one to limit, because in every point that we're considering, for example, if this is your graph, so this is your x, no. So in every x dito, there is a corresponding value of there's a corresponding value of y here. So this is your y, this is your x. So meaning to say, in every value, when x approaches a, or for some values, there should be a value of limit na not equal to an undefined. So we need to satisfy this condition for us to have a value, no, which is not equal to undefined. So the value of your denominator, or the resulting value of the limit of your g of x approaches, where x approaches a, should be less than or greater than 0. For another limit theorem, no, if a is any real number except 0, the limit of 1 over x when x approaches a, where your denominator is a variable x, no, we need to satisfy this condition. If a is any real number except 0, wherein your real number, these are positive numbers and negative numbers, and 0 is not included. Because if your denominator is equal to 0, then this limit will provide you an undefined value. That's why your a is any real number except 0. It should not be equal to 0. For us to come up with, or for us to use this theorem, no, we need to check, no, if the value of this a is not equal to 0. It can be less than or greater than 0, but not equal to 0. For us to provide a value of a limit, no, for us to provide a value of a limit which is not equal to undefined value. For the last concept of the limit theorem, so if a is greater than 0 and n is a positive integer, or if a, no, is less than or equal to 0 and n is an odd positive integer, then we need to uh, consider this one. So the limit of square root of n, no, n square root of x, no, when x approaches a, that will be equal to n square root of a. As long that we satisfy this condition, so you need to satisfy this condition, no, that your a is greater than 0, that will be furthered to n is a positive integer. Or it can be, or if a is less than or equal to 0, and that will be furthered to when n is an odd positive integer. Applying the concept of the limit theorems, let's deal with this example number 1. So we're asked to evaluate the limit of this x minus 4, x squared minus x minus 12 as x approaches 4. So there is a given limit here where x approaches 4. So we're asked to find the value of this limit, which is x minus 4 over x squared minus x minus 12. So in this case, we need to simplify first this denominator. So you need to look for the factor of negative 12 that once we add these two numbers, no, it can provide you a negative 1 here as the value of the numerical coefficient under your middle term. So what are the factors of this negative 12 that once we add these two numbers, no, it can provide you a negative 1. So that will be negative 4 and 3. So once we add these two, no, that will be equal to negative 1. So we satisfy this one, no? We satisfy this one in this condition if we adopt this negative 4 and positive 3 as a factor of negative 12, no? Once we're asked to simplify this denominator. That's why we came up with this idea that x minus 4 here over x plus 3. So we apply your ano dito, your positive here, positive 3 here is your positive 3 there. So your negative 4 here is from here. These are factors of negative 12 that can provide you a negative 1 once we add these two factors. So that will be negative 4 and positive 3. So since your numerator, no, is x minus 4 here, no, x minus 4, and in your denominator, no, is there is an x minus 4 here, and the operation between your x plus 3 and x minus 4 is multiplication. So we can cancel this one x minus 4 in your denominator. So that will be equal to 1 since x minus 4 over x minus 4 is equal to 1. So there is a 1 in your numerator dito. Then we copy the remaining term, no, or terms in your denominator. That will be x plus 3. Now, let's apply the value of this x, which is 4, no, since x approaches 4. So we substitute this 4 as a value of x here. That's why it's 4 plus 3. So that will be equal to 1 over 7. So your final answer, if you're asked to find the value of the limit of x minus 4 over x squared minus x minus 12 when x approaches 4, the final answer is 1 over 7. For example number 2, we're asked to evaluate the limit of x cubed minus 27 over x minus 3 when x approaches 3. Now, how we can solve this one? So using the concept of L'Hospital's rule, no, with this one, we're going to neglect this portion. So we're going to neglect this constant. These are terms, no, from your numerator and denominator that there is no involvement of a variable, no. So we're going to neglect them. So what we need to do is to subject this x cube, no. We're going to subject this x cube to derivative, then this x to a derivative also. So in taking the derivative of this x cube, you're going to subtract 1, no? You're going to subtract 1 in your exponent, so that will be x cube x squared there. Because we subtract in this one, so that will be 3 minus 1 in your exponent. That will be x square. Now, we copy whatever the value of your exponent in your given term. So that will be 3x squared. So the derivative of x cubed is 3x squared. Your exponent dito as your 2 here as your exponent is from 3 minus 1. Because in taking the derivative of this term, no, we need to subtract 1 to your exponent. Then we copy whatever the original exponent as your numerical coefficient before your variable x. That's why it's 3x squared. The same scenario with this one, no? So in reality, x is equal to x raised to 1. So if we subtract 1 here, so that will be equal to x raised to 0. right? From the concept in algebra, your x raised to 0 or any number raised to 0, no, that will be equal to 1. That's why in your denominator here, no, your 1 here is from this concept. Wherein if we're asked to take the derivative of this one, no, we're asked to take the derivative of this one. So the derivative of x is x1 x raised to 0. So this portion, no, is equal to 1. So therefore 1 multiplied by 1 is equal to 1. So therefore your denominator in this limit, no, in this term, no, so that will be equal to 1. So let's simplify. So let's apply the value of your x. So we use 3 since the given limit is x approaches 3. So we simply substitute this 3 as a value of your x in the given limit, no? Or terms na meron po tayo dito. So we simply substitute 3 as a value of your x. So that will be 3 multiplied by 3 square. So that over 1. So 3 square is equal to 9 multiplied by 3. So that will be 27 over 1. That will be 27. So therefore, the value of the limit of x cubed minus 27 over x minus 3 when x approaches 3 is equal to 27. For example, number 3, we're asked to evaluate the limit of 3x cubed minus 4x squared minus 5x plus 2 over x squared minus x minus 2 when x approaches 2. Now, in this case, no, if you try to look with this one, so we can simplify this one by using your synthetic division. So, synthetic division po ang ginagamit natin when we simplify your cubic equation, no? So, if we're asked to find the factors, no, in simplifying this cubic equation, then we use synthetic division. So since we're done with synthetic division in your algebra, so I'm not going to show this one, how to get these factors, no, by simply using your synthetic division, we can come up with these factors. So this numerator, no, it's a cubic equation. So once we simplify this one, by simply getting the factors of this by the concept of your synthetic division, then that will be equal to x minus 2, then multiply by x plus 1, then 3x minus 1. So in your numerator, in your denominator, I mean, so you need to look for the factors of negative 2. That once we add these two numbers, we can provide a negative 1 here as your middle term here. So we need to satisfy this one once we had add, no, the two factors of this negative 2. So the two factors of this negative 2, once we add these two numbers, it can provide you a negative 1. That will be negative 1 and a positive 1. That's why it's negative 2 here and positive 1 here. Now, if you try to look with your denominator and your numerator, no? So there's a negative x minus 2 here, x minus 2 in your denominator, x plus 1, both in your numerator and denominator. So we simply cancel out this 1, then cancel out. So that will be equal to 1. So therefore, that will be equal to 3x 3x minus 1 all over 1. So here, hindi na po natin ilalagay yung 1 dyan because hindi naman nakakapekto ng value. That's why it's 3x minus 1 in this portion. Now, let's apply, since nakasimplify na siya, so let's apply the value of your limit. So we simply use 2 as a value of your x. So we simply substitute this 2 to your x variable here. So that will be 3 multiplied by 2. That will be 6 minus 1. Then that will be equal to 5. So the final answer, no, or the value of the limit of 3x cubed minus 4x squared minus 5x plus 2 over x squared minus x minus 2 when x approaches 2 is equal to 5. For example number 4, Whereas to evaluate the limit of x squared plus x minus 6 over x squared minus 4 when x approaches 2. So for our solution, we're going to find the factor of negative 6 that can provide you, once we add these two factors, no, it can provide you a positive 1 here. So what will be the factor of negative 6 once we add these two factors? It can provide you a positive 1 here. So that will be positive 3 and negative 2. That's why if we multiply 3 by negative 2, it's positive 6. Now, if we add this one, so if we add this one, no, pag in-add po natin yan, so that will be 3 and negative 2. So it provide you a positive 1 here. So here is your positive 1. So you satisfy your condition for your numerator. So same thing with your denominator. So we apply the factoring concept, no. So once we factor out this one, since this one is a subtraction here, or a negative value of your second term, which is 4. Therefore, in your two factors, there should be a subtractions here, or a negative here multiplied by a positive. So since 4 is a perfect square, no, so both these two both this factor, no, if we try to factor this 4, so that will be equal to 2 and 2. And now, if that is a negative value, so what will be the value, or what will be the value of the factor of negative 4 that can provide you 0? Because here, there is a middle term here, no? This is equal to 0. So the factor of negative 4, that once we add them, no, it provides you a 0 as your middle term, or a numerical coefficient of your middle term that is equal to 0. So that will be your negative 2 and 2. Because once we add this negative 2 and positive 2, so that will be equal to 0. Now, let's try to assess, no, the simplified form of this fraction, no, using this quadratic polynomial. No, in your numerator, there is an x minus 2 and x minus 2 in your denominator, so we can cancel out. So the remaining term is x plus 3 in your numerator, and the remaining term in your denominator is x plus 2. So here, that will be the simplified form. Now, we apply your limit. X approaches 2, so we simply substitute here your value, which is equal to 2. That's why we came up with this, no, values that will be 2 plus 3, then 2 plus 2. So 2 plus 3, that will be equal to 5. Then 2 plus 2 is equal to 4. Therefore, the final answer for the limit of x squared plus x minus 6 over x squared minus 4 when x approaches 2 is equal to 5 over 4. So this will be the end of our discussion. So thank you very much for listening. I hope that you learned from me. I hope that you learned something from me. So if you have your suggestion, comment, or if you want to subscribe and do it. So that's it. No, thank you for listening. God bless to everyone.